Hello and welcome. We're really excited to have you here today for OCI Multicloud Office Hours. This is a monthly event for EMEA. For those of you who may be new to our events, we're hosted on Cloud Customer Connect, our Oracle community forum for end users. I'll share resources in the chat that leads you to the forums throughout the office hours today. And we invite you to create a free account and join in discussions. I'm Wei Han, OCI Multicloud Product Marketing Manager, and today we're joined by Sinan, Petrus, Toma, Principal Product Manager for Multicloud Mission Critical Database Deployment. And on our panel today, we have our OCI Multicloud expert, Julian, Ijaz, Ricardo, and Rahul. The office hour format will be a short presentation followed by Q&A for a total of 30 minutes. In this session, Sinan will first take us through the Oracle Database at Azure architectures. That's enough from me. Go ahead and take it away, Sinan.
Yes, thank you, Wai, for the introduction. Welcome everyone to today's session, OCI Multicloud Office Hours for Oracle Database High Availability and Disaster Recovery for Oracle Database at Azure. My name is Sinan Petrus Toma. I'm Product Manager in the Database High Availability Product Management team and focus on multi-cloud. In today's sessions, we'll talk about the high availability and disaster recovery, and also about the application high availability when connecting to Oracle Database at Azure. And also we have a live Q&A. If you have any questions beforehand, please go ahead and put those in the Q&A section. So let's start with Oracle Database high availability for Oracle Database at Azure. As it is based on Oracle Exadata and Oracle RAC, it inherits all the high availability features of Exadata and Oracle RAC. You know today from on-premises or from Oracle Database Exadata, dedicated infrastructure in OCI. Exadata provides network redundancy by having multiple network switches. When we create a VM cluster, we install Oracle Clusterware and the automatic storage management, ASM, as part of the Oracle Grid infrastructure to provide high redundancy, which is a three-way mirroring across the storage servers of the Exadata. Then we have database instance redundancy with Oracle RAC that runs every instance on a different database server. So we have our database with redundant storage and our database instances that are running on the database servers. And for sure, applications connecting to those database instances, if one instance fails, this is where the high availability comes in. Then end users and applications will be able to connect to the database through additional surviving instances, but also for planned maintenance. When we are patching the Oracle database homes, then we can also take one server off and the database is still available through other database instances. We can also add database servers and storage servers on demand for scalability and also for higher availability to have even additional database servers in case they are needed. And the idea is with the rolling patching or rolling updates is to patch one server at a time. So we patch the first server, then we go to the second one, and then to the third one. And during this entire process, the database is still available to the application. We can do this for patching the database server host operating system, the VMs, the grid infrastructure, the Oracle database, and for sure for patching the Exadata infrastructure itself. Here a reminder, when we are talking about database updates and patching, we are talking about either applying one-off patches, which are patches for single fixes that does not change the release number. We are staying on the same release number. We are just adding single fixes. Or if we are applying release updates or reuse, then we are increasing the version number, but the minor, but keeping the major release number the same, like from 1920 to 1921. Only the release update is increasing from 20 to 21, for example. While when we talk about upgrades, then we are changing the major version number, for example, from 12 to 19, or later on, probably from 19 to 23, see the next long-term support release. And for rolling updates for Oracle RAC, we can do this in a rolling manner. However, for upgrades, we will need a data guard. Then we will have a look at in a second. So with Oracle RAC, we have protection against database instances and local hardware failures. We can do rolling updates without downtime. And also we have an immediate failover. If the database instance fails, then the service either it is already opened on further database instances, or it can be opened immediately on additional database instances. The application doesn't encounter any downtime and continue working on additional database instances. However, as the Exadata infrastructure and Oracle database is in one data center, if we have an entire data center outage or a site disaster, then we would encounter downtime. And also when we have upgrades, we will need to take the database down, stop the database to have an upgrade to the next major release version. So you will encounter downtime. So to avoid this downtime, you will need to add data guard to our solution to provide disaster recovery and to provide zero downtime upgrade to major versions. And also remember, data guard is optimized for the Oracle database. It replicates the redo from in-memory to the standby database. It has an end-to-end validation. It protects against ransomware, against any corruption in the database, because data guard verifies and checks the blocks and the redo before applying it to the standby. In contrary to the basic storage mirroring, where the third-party mirroring solutions just replicate the blocks and the data as they are from the primary side to the secondary side. So if your primary side get corrupted or get encrypted by ransomware, then so will your standby database be, and then it is of no benefit to you to have a standby side or a secondary side that will be affected as the primary side. This won't happen with DataGuard, because DataGuard is built on top of the database. It is aware of the database structure and the database internal structure of the blocks. And if something happens on the primary, that won't be replicated on the standby if it is corrupted. And even goes one step further. If you have corrupted blocks on the primary or on the standby, these can be even replaced automatically from one side to another by the automatic block corruption detection and repair. The standby database can also be opened in read-only mode, or even in read mostly with Active Data Guard DML redirect. We can have automatic failover with fast start failover to have a shorter recovery time. We have simple migration and upgrades to the standby database. We can upgrade the standby database first, then switch over and then update the former primary database to reduce the downtime that is associated with the database upgrades. And also DataGuard is included in the Enterprise edition. license, so you don't need any additional options for that. You will need this additional active data guard option license if you are going to use the standby database in active mode, or if you are using one of the Oracle Active Data Guard features like the ML redirect. Okay, and then we can even automate the rolling upgrades with the DBMS rolling package, which also requires then the Active Data Guard option license. While the primary database is up and running, we upgrade the standby, then we do the switch over, and then we upgrade the former primary. In Oracle Cloud and also for Oracle Database at Azure, we have an automated deployment of Oracle Active Data Guard. The same feature and the same experience, from Oracle Database on Exadata dedicated infrastructure in OCI. You just log into the OCI console and go to your databases and click on Data Guard Association, click Enable Data Guard. You fill in the information if you want it to be in the same region or across regions, and then you click on Enable Data Guard, and then you are ready to go. For Oracle Database at Azure, you log into the Azure portal to create the Exadata infrastructure and to create the VM clusters. And then you log into the OCI console to create and manage the databases. So with Oracle RAC plus Data Guard in one architecture, we achieve protection against database instance failures, protection against site failures and disasters, patching and upgrades without downtime or with minimal downtime in terms of upgrade, because then we need the time needed for the switchover. This is here why we don't have an immediate failover in case of site failures, because Data Guard switchover requires, like, let's say 1 minute to 2 minutes, depending on how well it is tuned. In Oracle RAC, if we are switching or failing over from one instance to another, it is just an immediate failover without any brownout. And we can minimize the downtime for failover between primary and the standby data guard by using fast start failover. So for cross availability zone replication for Oracle Database at Azure, we provision the Exadata infrastructure in one availability zone. We create the VM cluster there, and then we create our Oracle RAC database. It is by default will be an Oracle RAC database deployed across all VMs in the VM cluster. However, if you have multiple database servers, you can choose the VM subsetting feature. So you have VM clusters that does not run on all Exadata database servers, but only on a subset of those. And when this is ready, you go and create a second Exadata infrastructure and an additional availability zone or another availability zone. And then you create the VM cluster there, and then you go back to the OCI console, click on your database that you want to protect using Data Guard, and click Enable Data Guard, and that will lead to automatically creating your standby database, also running Data Guard on the secondary site, running on that VM cluster that you have chosen through the Enable Data Guard process. Your application can access the primary database and or the standby database, depending on your configuration, if you are using Active Data Guard. For example, here we have an Azure Kubernetes service that runs VMs across both availability zones. So the application is also protected from availability zone outages. If you have an application that runs only in one availability zone, then you will need to think about replicating also your application to another availability zone to have your entire stack replicated and protected against failures. Here we have also the observer to take care of the fast start failover, also replicated to have a backup observer in case we switch the rules, and in case of any failures of the primary observer or even patching the primary observer VM. Additionally, we have automatic backups from the primary and/or the automatic backups from the standby database to OCI object storage. And we have the option to choose Oracle managed keys that are stored on the same infrastructure of the database, as you know, with the TDA, with the TDE wallets, or you can choose to use the OCI vault to create and manage and hold your TDE and encryption keys. For the cross-region replication, it is a similar scenario, except now the Exadata infrastructure is deployed across regions instead of across availability zones. Then we have the OCI vault replication also across region that is then going through the OCI backbone, and for sure your application replication you will need to take care of that will go through the Azure backbone, and we can have here again automatic backup to object storage in the different regions. And this is also a fully automated setup in the Oracle Cloud console, where you just go and select the database and say enable data guard, and this will lead to creating your standby database automatically in a second region. Having the database highly available, protected with Rack and Data Guard doesn't necessarily mean that your application is uninterrupted. So to have your application uninterrupted in case of outages or taking the database instance down or the database down for maintenance operations, we will need to follow best practices to create custom database services, use the scan VIPs or the scan name, enable notification services using connection pools, using the recommended connection string, and also using draining and application continuity. This is a huge topic that we cannot go very deeply into it today, considering the time we have. If you have any questions about that, just reach out to us, and we are happy to run a dedicated session with you regarding how application continuity protects and masks outages from applications, so you have even extends the high availability to your application, but not only to the database level. Further resources for you for the reading is the Oracle Database at Azure product page. And from there, you will see the frequently asked question page there, directly linked here. Very encourage you to read this page because most of the questions are already answered there. Very useful. We're extending this page as well, adding more questions and answers to that. On the Oracle Maximum Availability Architecture page, we have hybrid cloud and multi-cloud best practices, and also high availability overview and best practices for the Oracle database. Okay, so now coming to your questions.
Thank you, Sinan. We have a question there. Can we use data guard between Oracle Database at Azure and on-prem database?
Yes, you can use hybrid data guard, having your on-premises database replicated to Oracle Database at Azure, and vice versa. The data guard configuration will be manual in this case, so you just follow the standard Oracle Data Guard configuration, and then you are ready to go to build your data guard between on-premises and Oracle Database at Azure. If you want to automate this process, you could also use Oracle Zero Downtime Migration tool that also have the physical migration or online physical migration workflow, which is exactly based on building a data guard configuration. And the ZDM allows you to pause the migration process just after the step where the data guard configuration is set up, and then you just leave it as is, and you have your data guard set up between on-premise and Oracle Database at Azure.
Thank you, Sinan. Next question. What are backup solutions available in Oracle Database at Azure?
Yeah. The backup solution that is automated via the Cloud Console is to have automatic backups to OCI object storage. If you want to have the backups to another locations, then in this case, you can just log into the system. You have full access to your virtual machines, to the database, and then you just configure RMAN manually for a manual backup to any supported destination by RMAN, as you know it from Exadata dedicated infrastructure or from on-premises as well. At the end of the day, it is an Oracle database, but the recommended way is to have automatic backups today to OCI object storage. In the future, we are working on providing automatic backups to the autonomous recovery service, as it is today for the Exadata dedicated infrastructure in OCI. So to have also functional parity between Oracle Database at Azure and Exadata infrastructure running in OCI.
Thank you, Sinan. Jess, we have a few customers onboarding and right now, and some customers are doing testings. Is there anything you like to share?
Yeah, sure. Thanks, Wei. So I think, as you said, we have got customers coming to on the service, and the real use cases, I think, is a good one to share as such. So primarily, if customers have got on-premise Exas and they're looking for any upgrade, it might be on the recycle stage for their hardware, like typically from Gen 1, for instance, going to Gen 2 with the massive Azure estate. And I think that's been a really good use case we have seen across many customers already. And the other thing is the ease of the service in terms of the technology, where you have got local Exa available within Azure, is also another really key interest for those customers who are coming in. And commercially, obviously, the cost can be offset against their existing Microsoft commitments, Azure commitment, which is Mac. So I think those are really key things. So if any of the customers are on the call, they're looking into the use cases where they can adopt to at Azure, they should be considering those.
Thank you, Jess. Sinan, this question is for you. Does
Yes.
object storage backup support TDE / conversion and other features like ZDLRA provides?
Yes, automatic backups to OCI object storage are by default encryption and compression are enabled. And ZDLRA provides even more features, or the autonomous recovery service, which is based on the recovery appliance, provides even more like immutable backups and the virtual full backups, which is then incremental forever backups, and also provides the zero data loss. So the real-time data protection, which is this an additional features in the recovery appliance. For object storage, you have the traditional full backup, an incremental backup, or weekly full backups, daily incremental backups, and then the archive radio backups. And then you have like the recovery point objective, depending on the archive radio backup archival time. But with the recovery appliance, you have even much more. But for the question, yes, the encryption and compression are enabled for object storage backups.
Thank you, Sinan. Next question, if we're hosting Oracle Database at Azure, are there any additional charges for data transfers to and from the database server apart from Oracle license and the cloud storage costs?
Yeah. So the Oracle database at Azure provides the Exadata infrastructure within the Azure data center. Now, depending on where your application is in Azure, if it is in the same VNet or across other VNets or across another availability zone or another region, this then will depend on how you connect to, from where are you connecting to that database, because in Azure, network traffic might occur if you have network peering, and then this you will need to check the Azure pricing for ingress and egress network traffic across the Azure VNets. But from the OCI perspective, there are no additional cost while accessing the Oracle database, if you are accessing it from OCI, for example, or if you are accessing within the same VNet. So from the OCI, from the Oracle perspective, there are no additional costs, but you will need to check your network architecture within Azure, because in Azure there might be additional cost for ingress egress when you are using a specific network architecture. But this is not different from using any other network architecture within Azure.
Thanks, Sinan. Julian, do you have anything to add?
No, Sinan answered completely. So there is no Oracle charge for data transfer. The service is in an Azure VNet and in an Azure subnet. So you are in control of the network. There is no Oracle charge for the data. And then you can configure the VNet and the subnet using all the Azure topologies. So no Oracle data charge.
All right, we'll wrap it up. And we greatly appreciate your time, and a special thank you to Sinan, Julian, Nijas, Ricardo, and Rahul. Thank you. We'll see you next time.